I'm going to talk about the control of robotic parasitic antenna arrays. I'm Jeffrey Twigg, and my advisor is Dr. Nikhil Chopra. Wi-Fi and other UHF band communication between robots is poor and unreliable, especially in non-live site situations such as indoors, urban areas, and forests. A lot of research has focused on how robots can cooperate to relay data through a multi-hop network around large objects in these environments. But how can robots cooperate in other ways to increase communication in these challenging contexts? So I'd like to draw your attention to this robot with a low VHF antenna. As we zoom out, we can see that it has an omnidirectional array pattern, which means that it radiates equally in all directions. However, when we add antennas or robots to this first one, the array pattern changes. So this is actually very similar to a traditional parasitic antenna array that's often used for TV antennas. So how does this work? Well, in each of these situations, there's a robot or an antenna element that is connected to a radio. And then there are other robots with antennas that are passive, and so they're not connected to radios. And so these antennas re-radiate the energy from the excited antenna element, or the first robot in our graphic here. And so in the front of the antenna, you get constructive interference because these passive antennas are specifically placed, and you get destructive interference in other directions. And this constructive interference means that we get higher gain and greater range in front of the antenna. And so a key point here is that just as robots can cooperate to lift an object, robots can cooperate to create an antenna array to extend the range and increase directionality of a signal. In our research, we look at how to control these robotic parasitic arrays. We've developed theory and simulations on where robots should form arrays and what sizes arrays should be to maximize connectivity amongst a group of these agents. And we also looked at how robots forming one array can optimize their position in order to maximize signal strength and receive and transmit. Thank you so much, and I look forward to talking with you during the poster session.